7, section 3-4. Evaluate the limit x approaching infinity, factor. So what does this mean? You see, the numerator is actually one polynomial which has been factored. Denominator also is one polynomial which has been factored. If you want to use our previous methods, we could actually multiply this out and write down what exactly the polynomial is upstairs. Likewise, multiply these out. But why would we? We have a simpler approach. Because this is a rational polynomial, as always, we want to divide by the highest power of the denominator. Highest power of x in the denominator. So what would that power be? 7x and 8x. So x and x, the highest power is x to the power 2 in the denominator. If you multiply it out, the highest power and the highest power together gives you x squared as the highest power. That's the quantity you divide the numerator and denominator by. So that's your problem. Divide the numerator by x squared. Divide the denominator by x squared. Okay. Now I will rewrite this x squared as an x and an x. So I get one x for this factor, another x for this factor. Likewise, in the denominator itself, I take one x factor for here and one x factor here. Alright. So division distributes. So you have 11 over x minus 1, 5 over x plus 5. Denominator 3 over x minus 7, 8 over x plus 8. Okay. Now you set limit x approaching infinity. This goes to 0. You have only negative 1 from the first factor, positive 5 from the second factor. Downstairs, this goes to 0. Negative 7 from the first factor, this goes to 0, and positive 8 from the second factor. When you multiply it out, you get negative 5 in the numerator, negative 56 in the denominator, so positive 5 over 56. So let me remind you, you could, if you wanted, multiply these two factors and get a polynomial, multiply these two factors, get a polynomial, you will get the same answer. I'm simply dividing by x squared in the numerator and denominator and then separating out the factors little by little. Okay. Final answer 5 over 56. All right. Until the next problem.